Sequences, or more specifically, arithmetic sequences. We looked at these recently. So here is an arithmetic sequence. I've written down the difference, so it's clearly a constant gap between the terms. I'll just show the number, what terms they are. We're looking for the nth term. We don't know what it is, and we're going to use this formula. The nth term is equal to the difference times n plus the 0th term, the imaginary 0th term that goes somewhere along here. Now, we know it's going to be 3n because the gap is 3. As n increases by 1, so the term increases by 3. So you need to multiply n by 3. But there's an adjustment necessary because this would give us 3, 6, 9, 12 would be 3n. And the real series we're after is 4, 7, 10, 13. So how do we find the 0th term? Well, we put another 3 here. Now notice how when we're going this way, which is the normal way, we're adding 3. 4 plus 3, 7 plus 3, 10 plus 3, 13. When we're going this way, we're subtracting 3. 13 minus 3, 10, minus 3, 7, minus 3, 4, minus 3, 1. Get a bit of momentum up, and it carries you through to the 0th term. And so now the 0th term is 1, and we know that nth term is equal to 3n plus 1. And of course, we check that. Let's introduce the randomly selected 4th term. N equals 4. So this becomes 3 times 4 plus 1. 3 times 4 is 12, so that's 13, and we can see that the 4th term is indeed 13. Right, so what I'm trying to emphasize is that finding this first term requires going backwards, whereas this was adding 3's, this is subtracting 3's, and if you get a bit of a momentum up, hopefully it will carry you through to the 0th term. This is how I remember it. Nth equals dn plus the 0th term. And you can see that the n is carried over and it's got a d before it, and the th has carried over and it's got a 0 before it. Or we can be clearer. Nth term equals dn plus 0th term. I hope that helps. Or conceptually, you might think of it like this. Each of the numbers has a 0th term in them. It might be the base, if you like. And then each number is adjusted by a different number of d's. The first term has 1d. The second term has 2d's. The third term has 3d's. So you can see how easy that is to remember. N times d plus the 0th term. Here's an example. I'm going to scoot through this one fairly quickly. We put 4 here. We come back 18 minus 4, 14, minus 4, 10, minus 4, 6, minus 4, 2. So n equals, so nth term equals 4n plus 2. And that works. Does it work? Let's choose 2. Second term, 4 times 2, because we've now put 2 in where the n was, plus 2 is 10. And the second term is 10. Now, let's have a look at the complicated one. And the complicated one in all manner of maths is when there is a minus. Here the difference is a minus. Minus 3. 16 minus 3 is 13. Minus 3 is 10. Minus 3 is 7. And we do exactly what we did before. But instead of subtracting 3 when we go this way, we're adding 3. 7 plus 3 is 10. Plus 3 is 13. Plus 3 is 16. Plus, hold on, where is it? Plus 3 is, oh my God, 19. Got there in the end. So the nth term equals dn plus the 0th term, and that is equal to minus 3n because the difference is minus 3, plus the 0th term, which is 19. We can turn that around. It's the same equation. We just don't like starting with a minus. But maybe you just leave it like that. You're going to get the mark for this. This is perfectly correct. Let's check it. Does the nth term fit the sequence? Randomly chosen 3. The third term equals 19 minus 3 times 3. This is 9. That gives us 10. And the third term is 10, which is good. I hope this helps. I hope this helps find the 0th term. We'll have a little practice later. Thank you.